sure that it's all 100% food grade and certified that it's safe.
Right.
So can I step in here? So what is proprietary is not some other chemical that you're putting in there, but the actual blend of these food grade phosphates.
That is 100% correct.
Okay.
That you can pick from the 8, and you know it's going to be 3, 4, 5, 6, 7, or 8, but it's all going to be within that context. And the question is, what is the what's the percentages? And that's the only thing that we don't give out.
Well, that's really interesting, because one of the questions the community had when in proprietary was that somehow there was a secret chemical in there that was, I don't know, doing something that nobody knew about, but it's actually a mixture of phosphates that are all food grade.
Now, if we did something like that wasn't food grade, then we'd be in trouble. Yeah. And plus, NSF wouldn't certify it.
Right. Okay. Now, let me ask you one other question. I have a spec sheet provided by Aquasparm, and it listed out as Na35H5 P26085. So that is going to be the primary constituents in their relative quantities, right? I mean, is that basically what that's saying?
Not being a chemist, I would say that it is a formulation of the of phosphates, and I can't give you more than that because the person who developed that was the chemist who, our president. Who
right, and we're all struggling as lay people here, but we appreciate your help. So let me jump back to the guys with NSF. If the primary constituents are all sodium, hydrogen, P, what's P? Phosphorus.
Phosphorus is P.
Phosphorus and oxygen, and in those quantities, in those, do any of those primary constituents give you cause for alarm?
No, I mean, again, without disclosing what's the formulation that we have in front of us for this particular product, I agree with what the representative from Aquasmart indicated in terms of it's just a combination of these food-grade phosphates. And again, like I discussed earlier, consumption of these phosphates, the FDA has approved a phosphate and phosphate salts as food ingredients for decades. I think they determined they were generally recognized as safe back in the 70s. They did a multitude of tests, including genetic toxicity tests for essentially determining whether these can cause mutagenicity. And then there was chronic tests done in animals, and basically the tox data for these is very, there's a lot of data out there, and all of it's very good in terms of this chemical is just a very safe chemical. But again, once you start getting the huge dose levels, then yes, you can have issues. But you can say that for practically any chemical, even water. If you drink too much water, you can have toxicity issues.
Right. So when I look at this formula, I recognize, I believe sodium would be the metal component of this. Is that correct?
Correct.
Okay. Is that one of the metals you talked about as being regulated, or?
No, sodium is not something we would test for in terms of our regulated metals. Again, I listed out our regulated metals earlier, and those are the ones that are set forth by the EPA and have the MCLs that have been, for health effects. And those, again, to repeat that list, it's antimony, arsenic, barium, beryllium, cadmium, chromium, copper, lead, mercury, selenium, and thallium. And again, when we're testing this product at NSF, what we're looking for is the concentrations of these particular regulated metals, and then we would then extrapolate what those levels are based upon the maximum use level for this particular liquid product, which is 28 milligrams per liter. And so we would confirm that the levels of these contaminants, if they're even present, are below our pass-fail criteria when the product is dosed at that 28 milligrams per liter dose rate.
Gotcha. Okay, thanks. Let's see.
Can we ask these experts any questions?
Yeah,
we're getting there.
Second.
We just wanted to
so with regard to
baseline.
One of the arguments that was made early on, and this was by an operator that worked for the district a long time ago. One of the analogies he made was to phosphate that is in this product versus phosphate that's commonly used like in Coca-Cola. And his analogy was that you would get much more phosphate in Coca-Cola. But then, that statement was scrutinized quite a bit because the question is, well, is it really analogous? Is the phosphate in Coca-Cola truly similar to what would be, you know, the same kind of thing that's used in the water system or food grade or whatever. So I want to ask you guys, is that a fair analogy? I'm sorry, go ahead.
Yeah, this is Kevin at SW, and actually that is a fair analogy. The phosphate that's present in Coca-Cola is actually phosphoric acid, and that is a phosphate version, and that would be a phosphate that would be absorbed by the body if you consume Coke. And actually, I think Coke has, I can't remember, I think I saw it, that it was like roughly, I think 40 milligrams of phosphorus per 250 ml serving.
Okay.
So it's a pretty big amount. And so, but the reason that correlation actually works is that, I mean, even if you have polyphosphates or other chains kind of phosphates, the body will break those down into the respective orthophosphates to absorb them. And so basically it comes into, and by the time the body absorbs it, it's basically the same form. And so again, it's just the amount of phosphate that's being absorbed by the body. And again, phosphate itself is an essential nutrient. And the body can't synthesize its own phosphate, so it has to be ingested in the diet.
Okay. And let me ask you this, on a national level with regard to certification of products, is there an authority other than you that, are you the nationally recognized authority to set these safe limits?
Hi, this is Blake. The way that works is Standard 60 is the American national standard that was adopted by ANSI. ANSI is the American National Standards Institute, and so the official name of the standard is NSF ANSI Standard 60. And the standard was actually created at the request of the EPA Office of Drinking Water in order to address the health effects of drinking water treatment chemicals. What most of the state regulations will require is that products need to be certified. Any product that's added to a public water supply, any chemical that's added to treat a public water supply, needs to be certified to NSF ANSI Standard 60 by an ANSI accredited certification organization.
Sure.
So we are one of those. There's actually a couple of other organizations that conduct certifications to Standard 60, but this particular product, Sequest and Sequest Liquid, are certified by NSF.
Okay, very good. And do you guys happen to know how widely used phosphates are, how widely they're used in public drinking water systems?
I did see on the internet, says that 15 to 20% of public and private water systems use some form of phosphate in the treatment of drinking water, and that's this is actually on the website for Caris Chemical, which is another phosphate manufacturer. There may also be some publications from organizations such as the American Water Works Association.
Yeah, and I tried to get them on the phone today. They couldn't be here, but they do have that information. And do you guys happen to know how long they have been used? Like, was it since the 80s, 70s, or how long have they been generally used in public drinking water systems?
I'm reading on a website here.
Are you asking how long phosphates have been used generally for water treatment?
Yes.
Correct. Yes.
Our program has existed since 1988, so I'm reading on the internet to see if I can find out when this first started, when use first started.
Because I've read that they were used in water tanks, you know, above municipalities first, and that's been happening for about 70 years. And then it started getting introduced to the distribution system in the late 70s, early 80s.
Okay.
Okay. I'm reading here, first use of polyphosphate for drinking water in 1929. I don't know if it was as widespread at that time, but there was some use going back quite a few decades.
Okay.